All right, so we're the group of machine enclosure and nameplate, and we're machine press studs. I'm Andrew Costa,
I'm Jake Edwards.
and we're just going to run you through what we're going to go through in this presentation.
So in this presentation, we're going to be talking about NEMA nameplate information, NEMA nameplate, as well as NEMA frame information, NEMA installation classes, NEMA enclosures, and to start to end it, site sourced. So NEMA nameplate information. By NEMA standards, every NEMA nameplate has to have these requirements. They're required to have manufacturer's type, rated volts and full load amps, rated frequency and number of phases, rated full load speed, rated temperature rise or installation system class, time rating, rated horsepower, locked rotor indicating code letter, service factor, efficiency, frame size, and design code. So starting off with NEMA frame information, under NEMA, most motor dimensions are standardized and categorized by frame size, number, and letter designation. NEMA frame size refers to mounting only and has no bearing on the motor body diameter. NEMA frame sizes are identified as either 2-digit or 3-digit numbers. So continuing, 2-digit frame numbers. They are fractional frames, even though they can have 1 horsepower or larger may be built into them. The 2 digits represent the shaft height of the motor from the bottom of the base in 1/16 of an inch. For example, a 56 frame motor would have a shaft height D dimension of 56/16 of an inch, or 3.5 inches. 3-digit frame numbers. The first 2 digits of the frame size divided by 4 equals the height in inches of the shaft center line from the bottom of the mounting feet. The third digit represents the distance between the mounting bolts, but does not have a direct measurement. The higher the number, the longer the distance between the mounting bolts. For example, a 326T frame would have a D dimension of 32 divided by 4, or 8, and an F dimension of 6.
Moving on to installation classes / ratings. So you can see by this chart, there's a couple of things to look at here. So determine the class of installation. Use there's only a little bit of math involved. So the ambient temperature, which is always 40%, that's a reference point, allowable plus the allowable temperature rise for 1.0 service factor, plus the allowance for hot spot wiring, which is what's given on the chart there. So for an example, it's 40 degrees of the ambient temperature plus 125 degrees Celsius of the allowable temperature rise plus the 15% hot spot would give us 180, or class H insulation. And a fact for insulation, so for every 10 degrees increase in temperature decreases the life of the insulation by half, and opposite for the temperature if it goes down. So for every 10 degrees decrease in the temperature, there's double the life of insulation. So to determine what the motor service factor would be able to achieve in a Class B motor with Class F insulation, so that would be common to have, would be like so. So for a service factor of 1.15 with Class F insulation, a Class B temperature rise at full load converts to a thermal margin at 155 minus 40 plus the 90, which gives us 25 degrees Celsius. So in translation, that would be 4 to 6 times longer than it would have if it would just be regular Class B insulation.
So moving on to NEMA enclosures. Enclosures classify the motor as its degree of protection from its environment and its method of cooling. In other words, there are many different types of enclosures for either hazardous or non-hazardous environments. Motor enclosure types can either be open or closed depending on its surrounding environment, each with a specific method of cooling.
So for this, we have an open enclosure. Motor enclosures are commonly used in dry environments where not a lot of debris or moisture can be entered the enclosure. The enclosure allows for air to pass over the internal windings. Enclosed motor enclosures do not allow for free exchange of air into the internal windings and have their own methods of cooling, such as fan or ventilation, dust, duct, convection, etc.
Continuing, some common examples of enclosure types in non-hazardous environments include drip-proof, usually indoor. They have an open enclosure, ventilation openings, and shield prevents drops of liquid from falling into the motor within a 15-degree angle from vertical. Moving on to totally enclosed, non-ventilated. So there's no ventilation openings, completely enclosed but is not airtight. It doesn't allow free exchange of air around the windings and relies on convection. As well as the totally enclosed fan cooled, same as the TENV, except it has an internal fan and provides a cooling system of blowing air onto the outside of the motor. There are also hazardous location enclosures, such as explosion-proof enclosures. The motor is designed to withstand an internal explosion of specified gases or vapors and not allow the flame or explosion to escape.
Before we get to our reference, our only reference, we'd like to talk about electrical standards. We decided to stick with NEMA as a standard because they are the governing body on an international level for all electrical equipment. It's important to have these standards in place because it gives everyone a reference for when choosing electrical equipment, no matter the location. This addresses the main concern of everyone's safety and enables the people who work on electrical equipment the ability to easily identify what is used and how to safely operate certain machines. So that pretty much wraps up our presentation on NEMA nameplates and standards, so I hope you enjoyed.
Thanks for watching.